Okay, so hello everyone. I welcome you all to the next session of Automation in Manufacturing. This is a course offered by NPTEL under the course code of NOC 22 ME133. I am Swarit Anand Singh, PhD student in the Department of Mechanical Engineering. I am a PMRF fellow. Through this PMRF and NPTEL TA scheme, I got this opportunity to interact with you to take this live session for solving your queries and doubts regarding the course. So this is the sixth session. Before this, we have conducted 5 sessions, and all the sessions are now on the YouTube also. So if you have missed any of the session, you can join. You can watch the recorded lecture of this session on YouTube. So as the number of student in the class is low, we'll wait for some time and then we'll start the session. So today's session will be focused on the course content that is posted in under week 6. So we are going to cover the doubts and questions related to the syllabus that is related to the topic that are covered in week 6. So I hope you all have gone through the course content, the the content that is posted on the portal, NPTEL portal. And if you have any doubt, you can ask me. So all those who are in the class, if you have any doubt, you can ask me before we start the session. Is there any doubt to anyone? Anyone want to say something? Any question or anything? So as our earlier session was going on, we will continue the same pattern in this session also. So the session will be divided into 3 sections. So first section, I will be giving you some questions that will be objective type or maybe numerical solving. So we'll be solving the questions together, and after that, we will move to the. We'll take the questions that are posted on the discussion forum, and later will be again open for one-to-one interaction. And if you have any doubt, you have any query, you can ask at that time. Even if you have any query or any doubt comes in between at any point of time, you can feel free to ask, and I will be happy to answer all the queries and clear your doubts. So today the strength is very low, bit low in comparison to the other sessions. So I'm just waiting for 2 minutes more. We'll wait for 2 minutes more, and after that we'll start the session. So till then, if you have anything to say, anyone want to say something, you can ask me. So let me ask you something. How this course is going on? Like, are you guys uh, getting interest in studying this course, or what? How is the course content? Any feedback from your side? Anyone can unmute yourself and feel free to speak. Sridhar is saying content in the lecture notes is less. Okay. Okay. So in the feedback form, which is present there on the NPTEL portal, you can fill this thing. Whenever I will have a discussion with Professor Joshi, I will definitely convey this information to him. However, this course is a very vast course, like it is covering a different field of electrical, mechanical, electronics, and maybe some part of computer science. So he is like trying to like the course is binding all these different domains in uh, a single packet. So you may find some content maybe less in amount, but that is for providing you some basic introduction to the topic. If you are more interested, then maybe some you can, in a particular topic, if you are more interested, you can do some specialized course also. There's like, or else I will convey this information to Professor Joshi that there is this kind of issue. Abhishek Pawar is saying the content is exposing us to newer subjects. Yes, yes. So this is the ultimate objective, ultimate aim of this course, that you should uh, get exposed to the newer domain, newer topic. So if you see the people who are here, they are from different background and different domains. So you can find people from electrical, people from mechanical. We have students from computer science branch, or maybe some other related electronics branch, instrumentation branch also. So all are here to get the information, or to get exposed to the knowledge which they are not, or which is different from their field, right? So if we are studying about this motors and electrical things, electronics things, so it is totally that we this is very new for the person who is a mechanical engineer, or who is pursuing his degree in mechanical engineering, right? So if you are a electronics engineer, then you don't know about what is casting, what is lathe machine, what is this kind of thing. You are less exposed. So through this course, because in the current era, the demand is obviously automation. So this automation is not a demand of current era. Actually, it is a demand of previous era. So by previous era, I mean that industry, there is a revolution of industries, right? So the revolution of industries is started like industry 1.0, first industrial revolution that is called, and then second industrial revolution, third, and now we are in the era of industry 4.0. You must have heard this term, industry 4.0, smart manufacturing. So we are in the era of this industry 4.0, and this automation came way back in like with the second generation of this second revolution of this industrial revolution. So their automation has arrived at some extent, but it is fully capitalized the market and the industries in the third revolution. So in the third revolution, when computers and this controllers were introduced to the domain of manufacturing. So uh, so at that time, this automation keep start growing, right? So from that era, now we are in the one level up, fourth industrial revolution, industry 4.0. Now the demand is much more than this automation. So but however, like we surpassed like the third era of industrial revolution was not stayed for a very longer period, because the rapid evolution of the newer technologies. So this industry 4.0 came, but Indian factories, SMEs, MSMEs, like small medium scale enterprises, which are mainly like which are the major industries in our country, they are still in the transition phase, right? So they are still adopting at automation at some level. Some has already adopted. They are going toward industry 4.0, but most of like industries which are at working at a small scale, so they are less they have less implemented this automation. Now they are, because the market demand is high and everyone is putting the automation, so they are implementing this automation. So since this automation is in demand, so we will require a workforce which is trained for building this automation facilities, and to automate the system, to automate the what I can say, a factory, something like that. So that's why this course is very important for all of us, right? So either you belong to electrical background or maybe mechanical background or some other else, but at a point of time, if you are a mechanical engineer, you must have some work to do with, like, which is not from your background, that is from electronics background, but without that, your machine or the thing that you want to build will not work. So that's why the information is required, and the people are more interested toward this kind of knowledge. So this course has been floated with this aim and target also, so that people can understand what is automation, and especially in the manufacturing domain. So what is the role of automation in the manufacturing domain, and how we can implement this automation in manufacturing domain, right? Okay, so we'll begin with the today's session. So today's session again, first of all, I'm going to give you some questions. So I just want answers from you guys. So please participate in this session. So if you will participate more, it will be very motivating for me also, so that I can deliver with my full energy. Okay, and that will be obviously helping you all, so that the more we interact, the more knowledge will comes out. Okay, and more whatever information will comes out, and more knowledge will gain, right? So with this note, I'll start the session, the first part of the session, that is the question answer session. So question answer round. So the first question is on your screen now. The question says it is a true false statement. Okay, you have to decide that the statement is true or false. The statement is, the ideal drive should have extremely small positioning resolution. Is it a true statement or a false statement? We are talking about ideal drive. So what is required for ideal drive? Should it have extremely small positioning resolution or a high positioning resolution? So T. Shankar Lal and Mukut have already answered. It is true. Okay, someone else want to answer? Okay, so no issue. The answer is true only, because for an ideal drive, we obviously we want a very small positioning resolution, and we are tending to achieve microns, the resolution in terms of microns. Okay, so up to 2 microns or 1 micron if we get, so that will be very efficient drive, or that will be an ideal drive. So now second question is on your screen. Second question says synchronous motor is a variant of which type of motor? AC motor, DC motor, digital motor, or shunt motors? So synchronous motor, that you have studied in your course content, you have already seen this. So to which variant this synchronous motor belongs? Abhishek Pawar is saying AC, Chandra Karma is saying AC, Mukut. Okay, yeah. Yes, so definitely it is an AC motor. The synchronous motor belongs to an AC motor category. So here is a short clip of, like, what is a synchronous motor and how it has been constructed. So please have a look over it. So it says, like, excuse me, just I just want to play this. Maybe it is not getting played. Just give me a second. Just give me a second, because I have presented Windows. I think that's why it was not able to play that. I'm presenting the whole screen now. I hope my screen is visible to you all. Okay, come to it. Cannot play media. Okay, so let me show you the video directly. I'm sorry for this mismatch. Just tested it, it was working, but it's now not working. Okay, so here it is showing the how this synchronous motor has been like built. So as you already know, there is a stator and a rotor. So these are the outer part are the stator, and this inside it the rotor is fixed. Rotor is there, placed there. So with the generation of this magnetic field. So once the magnetic field, both like north and south, north poles are get in a synchronous mode. So the rotation of the rotor will be in a like in synchronization with uh, the field that is generated by the rotor. Sorry, the stator. So this is why this kind of AC motor we called it as a synchronous motor, because the frequency, uh, the rotation of this rotor of this synchronous motor is in is sync with the what you can say with the frequency of that applied current, and the magnetic field that is generated in the stator. Okay, so third question is on your screen now. Third question says, in a CNC turn machine tool, the feed drive is used to. The feed drive in the CNC turn machine tool is used for. So CNC turn machine means what? CNC turn machine is nothing but a turning CNC lathe. Okay, so CNC lathe machine you can say. So it's a turn machine where the turning operation you can perform. So there's a CNC lathe machine, you can say. So Chandar, Mukut, and T. Shankar Lal says C is the answer. Okay. So yes, C is the answer, because this feed drive that is used, uh, it is used for providing the relative motion between the tool and the workpiece. So as you all know that in CNC lathe or any lathe, so the lathe is meant for like turning operation majorly. So where the workpiece is fixed in the chuck of the or spindle of the machine, lathe machine, and it is rotating. Okay, it is rotating on its axis. So this workpiece keeps rotating, and the tool is there, which is mounted on the feed drive. So it keeps on moving, and the movement is defined by the operator, or like manually or through some code. So that movement provides the relative motion between tool and this workpiece, and due to that motion the cutting action has been performed. Okay, so for that purpose this feed drive is used. So you can like you can see sketch of a feed drive. So there is a drive where the motor is placed here, and what you can say screw nut ball arrangement is there. So this screw is there, and once this screw is attached with this shaft of this motor, so once the motor rotates, this also keeps rotating, and because here there is a teeth. Okay, so helix is there, so it keeps rotating, and then this nut, just like our simple screw and nut arrangement, once you like uh, when you take the nut and bolt, so you keep like either rotate the bolt or rotate that nut or that screw, so it will either goes like inside or it comes outside from that. So similarly, similar operation is happen here. Okay, so because of that rotation inside this the rotation of this screw, the nut inside this keeps either it will move in this direction or it will move in this direction depending upon the direction of the rotation of the this screw. Okay, and that provide the motion to the tool either in this direction or in this direction. Or if we align this axis into like if we rotate it by 90 degree, so it will provide the motion to the tool in this direction, right? So this feed drive is used for that's uh, providing the relative motion between the workpiece and the tool. So we are moving to the next question. Question number 4 is on the screen now. Question number 4 says electric drives are required in the automation of equipment for. So we already have studied what are electric drives. So where these electric drives are required for making this for imparting the automation. So in the equipment. So the equipment belongs to production operations, CMM based inspection, conveyor based transport, or all of these. So T Shankar Lal says the D option, that is all of these. Chandar Karma is also saying D. Okay. Yes. So answer is D obviously, because in production operation or CMM based inspection or in conveyor based transport, we use electric drive for different purposes. Like for position, sometimes we use it for positioning the tool. Sometimes it be used like in conveyor we use to transport the product from one end to another end for transportation of the product. In CMM we use to move the positioning of that probe. Okay, so for positioning that probe we use that electric drive. So for this kind of for the automation of equipment, all of these mentioned scenario, electric drives are required. Now this is a very simple question which belongs to a 12th class physics only. So the question says, in the context of DC motors, when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force whose direction is given by which rule? Taylor's left-hand rule, Fleming's left-hand rule, Faraday's left-hand rule, or Faraday's right-hand rule, or Fleming's right-hand rule. Yes, yes. So yes, you all have studied this. So this is a very simple question, and answer is yes, Fleming left-hand rule. So this is a Fleming left-hand rule. Just for a recall, I just say. So just put your what you can say left hand like this. So the thumb will show the direction of the mechanical force that is that will observe. Then this finger shows, like in the figure also, this finger shows the magnetic field generated, and the middle finger will show the direction of the current. Okay, so using this is a rule is known as Fleming's left hand rule. So we have studied it in like very detail, where we can say like we have already gone through the formula like F is equal to B L sine theta something, and then it is also multiplied by current. So IBL sine theta. So this IBL sine theta, L sine theta is the positioning of this wire. Okay, where the electric current is flowing. I is the current, B is the magnetic field, and F is the force that is experienced. So all these are the vector quantities, right? So because of that, so with the help of this Fleming's left hand rule, we used to find any of this. If two like there are four variables, so two are given, three are given, and one we require to find out. So with the use of this formula, we used to find it, right? So generally, the sine theta is equal to 90 degrees. So generally, this formula becomes like at lower level we used to study like this, F equal to BIL, right? So because just this this theta, like that, the angle between this the magnetic field and the conductor, the current carrying wire is 90 degrees. So this, because of that, it becomes like this. Okay. I hope you all have got some more insights about this Fleming's left hand rule. Now moving toward the next question. So the next question is on the screen now. It says the split ring commutator assembly arrangement is generally used in which kind of motor? The options are brushless DC motor. Okay, so you have given the answers also. Okay, so brush DC motor is the answer. Uh, okay, so let's see the working of a DC motor. You can say. I'll try to play the video again. If it will not play, I will. Yes, again there is a problem in this video also. Don't know why it is happening today. Before it, we were playing this videos here only. So we have to go to that folder. Okay, so here you can see on the screen. So uh, this is the what you can say. These are the magnets. Okay, and this is the electrical. This is a wire which is carrying the current. Okay, so due to that current and this magnetic field that is there, so a force is applied over on this wire, and since these wires are connected with this commutator, so it keeps rotating. Okay, and then further a shaft is attached to it to get the conversion of like electrical energy into some mechanical rotation, right? So these are the brushes, you can say. So these are the brushes, and these are the ring shape structure which are split ring. Okay, so if we increase the number of split rings, so the amount of torque we will get is more. Okay, so this is how the current is flowing. We apply what you can say DC uh, uh, power to this, and due to that the rotation and the force the rotation of this the current carrying conductor happens, and due to that we get torque, and that this part is connected with the shaft, and on the shaft we get the mechanical energy. So let's move towards next question. I hope you have got some further insights in the how this DC motors look like, and how the brushed DC motor like work. Right. So moving to the next question. Question number 7 is on your screen now. Question number 7 says, in which type of motor the rotor travel at the same speed as the rotating magnet field is generated by the stator winding? So Bavo, in the video, I was not playing the voice, right? I think you're talking about that voice. I am audible, right? Can somebody confirm? My voice is audible. Okay, okay, Abhishek, thank you. Yes, so answer for this question. Okay, so I got different answer for this question. No, so again, we read the question with a like more. Okay, so it says like the question says the rotor has to travel in the same speed. Okay, so these are the keyword, same speed as the rotating magnet field is generated in the stator winding. So just before we saw a video where if the speed of the rotor is equal to became equal to the speed or the magnetic field that is generated, like magnetic field that is generated by the stator winding, so it is become the what you can say AC. This is the type of AC motor. Okay, and that is a synchronous motor only, right? So I'm moving to the next question. This is a numerical to solve. So you have to solve this question. The question is, if the synchronous speed of a inductance motor is 800 RPM and the actual this is the 800 RPM, and if the actual speed is noted at 780 RPM, then the slip in the motor will be, in percentage. We want the answer. What percentage of slip you can observe in this kind of scenario? So I hope you all have studied this part in the course, and you must have gone through some formula and a concept of slip also. So we have to calculate the percentage of slip that is observed once, like in the if the inductance motor is running at the speed of 800 RPM and the actual noted speed is only 780 RPM, means we have lost 20 RPM speed, right? So this 20 RPM speed we have lost because like 800 RPM was the actual speed and this 780 RPM is the speed that is observed. So this 20 RPM we have lost. Oh, so T. Shankar Lal has solved this and given the answer also. Very nice. So I appreciate your effort, T. Shankar Lal. So yes, you have correctly answered the question, and I am talking about this formula. So all those who are not aware of this, this formula is there in the lecture note. Okay, so this is the formula for slip percentage. Okay, so what is there? If the speed of the like synchronous speed and the actual speed have some difference, so what will happen? Like there's a 20 like 800 was the synchronous speed and the actual speed was 780, and then divided by synchronous speed. So we got it like 20 by 800, and when we multiply it by 100 for the percentage, we'll get it like 2.5%. Right? Yes, Abhishek also giving the same answer. Yeah. So I hope this concept is now clear and you will be able to solve further more question related to this topic. Is there any confusion to anyone? Please let me know. Okay, so we'll move to the next question. Next question is again a numerical for you. So this question belongs to a stepper motor slides. Okay, so a stepper motor needs 60 pulse to rotate through one complete revolution. Okay, so this is we can say revolution or we can say rotation. Okay, so here you don't get confused with that term. Okay, so through one complete revolution, input signal is 180 pulse per second, will make the motor to rotate at what RPM? Like we want the speed of the motor, right? So if the motor needs 60 pulse for one complete rotation, right? So Pawan is saying the answer is 180. Okay, we'll see some other answers. Maybe some of you are solving. So I hope you got the question right correctly. That 60 pulses are required to rotate to for one rotation. And now what it is saying, that 180 pulses are provided per seconds. 180 pulses per second is provided to the motor. Then what is the speed of the motor? Like RPM means rotation per minute we want. Rotation per minute that we want. So Abhishek is also saying 180. Okay. One, two more answer, then we'll solve this question and we'll check the answer. So like for one rotation, if it is taking 60 pulse, then in 180 pulses, how much rotation it will take? for if for 60 with the help of 60 pulses it is doing one rotation, then in 180 pulses it will do 180 by 60 number of rotations, that will be 3 rotations, right? And since it is getting 180 rotations per second, so it will be like 3 rotations, 180 pulses per second, so it will be like 3 rotations per second, right? Yeah. So if 3 rotations per second, then we want the answer in terms of rotation per minute. So what we need to do, 3 into number of seconds in a minute, so it is 180 only. Yeah. So the answer is 180, right? So now for more clearance on this topic, like because this is a very important topic, you can say you must study this stepper motor very like attentively. Okay, because this stepper motor, whenever there is automation or any motor is required for automation, you must require this kind of motor. Either you will require a stepper motor or servo motor or something like that. So for positioning and all, we required this kind of motor. So the calculation of this motor and how we have to select this the respective motor. So we required this calculation. We must know how to calculate all the things, all the parameters for that. Okay. So these are the some formulas that works for you. Okay. So if we want to calculate the motor speed, so the motor speed will be like in the terms of rotation per second here will given by step angle. So step angle beta, and then the frequency like pulses per second. So how many pulses it is giving supplying to the motor, we are supplying to the motor, and divided by 360. So this is step angle by 360, and then this frequency will give us the motor speed in rotation per second. Again, this is a formula that you have seen in the lecture slide. Rotational speed in RPM will be like multiplied by this same formula. The formula is same, okay, and it is multiplied by 60. So the second is converted into minute. So it become this will give rotational speed in RPM. And then if you want to calculate the step angle, so it is given by number of poles on rotor minus number of poles on stator into 360 upon multiplication of this number of poles on rotor and stator. Okay, so using all these concepts, we are now going to solve a comprehensive question. So the first question is on the screen. Okay, so answer is also there. No issue. Just solve it and check whether you are getting the answer or not. The question is like a stepper motor has a step angle of 2.5 degree. Calculate the number of steps required for the shaft to make 25 revolution. So what we are going to see, like we are running out of time, so I'm going to just solve the question for you, and we will keep discussing the concept also. So the stepper motor has a step angle of 2.5 degree. Okay, so in one like one is in one step, like it is covering 2.5 degree. Okay, so how many steps will be required to cover one complete revolution? So it is like 360 degree you want, right? So for 360 degree, how many steps? So we'll divide it by 2.5 degree. What is the answer? Yes. So this is 144, right? And then this 144 is the number of steps that it has taken. So in one, if in one revolution it is taking 144 steps, then how many how many steps it will take for 25 revolution? So for 25, you just simply multiply 144 into 25, and the answer will become, yes, 3600. So this is basically based on a very simple mathematics calculation. Okay, so we just have to follow the concept. I hope you all are able to get this answer only. If someone in the class gets some other answer, please let me know. Okay. So now moving to the next question, which is again connected with this only. The question says, if 72 pulse per second is supplied, okay, so for this motor only, the motor that we are dealing with, this is stepper motor only. If the 72 pulses per second is supplied, okay, so now the pulses are given. What will be the motor speed in RPS and RPM? Any answer? So what it is saying, in 72 pulses are supplied, okay, per second. So I'm not using any formula. I'm just going through the concept only, right? With the concept, we do not require to remember the formula. So there's a direct formula. You can apply the formula and get the answer. But yeah, what is the concept behind that? You can just have a understanding of that. So if 72 pulses are supplied per second, it means this motor, which is having step angle of 2.5. Okay, so in one pulse it will rotate 2.5, right? So how many like pulses were required for the complete rotation that we have already calculated? That was 144, right? So 144 pulses were required for one complete rotation, right? So it is supplying 72 pulses per second. So for one rotation, for 144, for 144 pulses, how many for 144, like this 144 is the number of pulses that required for one rotation. Okay, so for one rotation, if the 72 pulses are supplied per second, then how many what is the speed? We have to calculate that. Hello, I'm audible to you all, or are you guys solving the question with me, or just okay? Okay, Abhishek. So yeah, so we are talking about this same. What we got, please? Yeah, 144. 144 was the number of pulses that are required for one rotation. Now, if it is supplying 72 pulses per second, then what is the speed? Yes, yes. Someone has given some answer in RPM. Yes, and for seconds, what we do, we do not require this. So this is the answer in RPS. And if we convert like for minute, we have to multiply it by 60 to 2 into 60, it will become 120 RPM. Any confusion in this? Okay, so we'll move to the next question. So what is the time required to complete this 50 revolution? In continuation with this only, this question only. What is the time required to complete the 25 revolutions? This 25 revolution will be completed in how much time? Yes. So Chandar is writing, have written the correct answer. So before that, we have calculated that 2 RPS is the 2 rotations per second is the 2 rotations per second was the speed, and for 25 rotations, we just multiply it with the. So what we'll get? We'll get 50 seconds, right? So in 50 seconds, it will complete 25 revolutions. So since it is taking 2 seconds for one revolution, so for 25 revolution, it is 50. Okay. So the concept of this stepper motor, it is just based on the, what you can say, unity theorem. Okay. Just like a simple mathematical calculation, that if in like from our childhood, we used to calculate, like, so if some chocolate comes in 2 rupees, then if I have 10 rupees, how much chocolate we'll get. So similarly, if we have to proceed with the calculation of this stepper motor also. So without getting any confusion, you have to solve the questions or the numerical related to this stepper motor. So you can furthermore explore the questions and the numericals related to the stepper motor, and then solve. And if there is any query, we can you can come back to us and we'll discuss. So yes, Chandar, you have raised your hand. Any query?
Hi, sir. Can I
Yes.
have, can we have some template paper or some, what sort of paper we will have in exam? Is it same
Uh,
like objective type or any other discovery type?
so for that, I don't have the information.
In the
Correct.
this is the first time you are going to
Yes,
conduct
yes.
this one?
I'm doing first time the TA for this course. So I will ask
Okay.
with professor, and I will get back to you in next session. Okay, I'll try to answer this question
Okay, fine, fine,
because
sir,
I
fine,
don't
sir.
have correct answer for my like, as per my knowledge, for different for other courses that previously, like when I was in master, so there were some courses that were floated by NPTEL. So in that, they used to take a general, like that examination which we used to usually give, like descriptive type questions were there. There is one word answer question, then fill in the blanks also. So that question paper was mix of like all things. So it was of descriptive type also, and then multiple choice questions were also there. So for this course, maybe I have to confirm with Professor Joshi, and then I will be able to answer that.
I have been through all the course contents, right, in the
Okay, okay.
PPT and YouTube. I don't think so. There is a too much contents we can put in a descriptor, right?
Okay.
Multi-option, there is a lot of possibility, and a small answer, then a small calculation like
Yeah, yeah.
right.
Small.
So
Yes, yes.
that's why I'm in confusion, sir.
Mm-hmm.
If not
Okay,
that,
so I will ask to Professor Joshi, and I will
perfect, sir.
ask.
Perfect.
Yeah,
Okay,
yeah.
okay.
Yeah.
Thank you.
Thank you.
Thank you very much. Thank you, Mr. Singh.
So, so are we doing some wrong mistake, or are we doing some mistakes here? Anyone? If you have solved this question, then can someone confirms that we have done some mistake here? The answers are incorrect for this particular question. This question number second. Yes. Units file division. No, Abhishek. So I stopped for that moment. So I was just, because this was a what you can say. This is a mistake that I have done in the calculation while I was making this slide. So the question arises while I solving this numerical here. Okay, so I took this question from somewhere and just copied the answer. I hadn't solved this question. That was my mistake. But when you are going to solve this question, what you are seeing? Okay, so you are seeing like 2.5 step in one pulse. Okay, so how many pulses for 360 degree of rotation? 360 divided by 2.5 will get 144, right? 144 pulses are required for one revolution or one rotation, right? If 144 pulses are required for one rotation and it is providing 72 pulses per second, so 72 pulses are provided in 1 second. So for completing this 144 one rotation, we required 144 pulses. For one rotation we required 144 pulses, right? So if if it is giving 72 pulses per second, so for this will take 2 seconds to for this revolution, right? 2 seconds for one revolution. So what will be the speed now per second? If we want, like, in 1 second, how much we'll able to rotate? Will rotate only 1 by 2, right? 1 by 2 rotation per second. That will be 0.5 rps. So this is a mistake. This answer is wrong, right? And based on that, again, this answer is also wrong then. So the correct answer is 0.5 rps. Okay, and then we have to multiply it by 60 for rpm. We'll get 30 rpm. For this, time to complete 25 revolution. So for one revolution, if it is taking 0.5, if for one revolution it is taking 2 seconds, right? So for 20 revolutions, it will take 2 into 25. So it takes 50 seconds. So this is right. Okay, so I hope you got the correct answers, and I'm sorry for this mismatch. I just copied it from somewhere, so I didn't solve it. It's my mistake. I really apologize for that. I hope the concept is clear to you all now. Moving to the next question. The question number 10 is on the screen now. It is again a multiple choice question. It says in a variable reluctance stepper motor, the rotor is made of which material? Yes, so answer is ferromagnetic material. Okay, so this is a direct question from the slide only. Now I'm going to take some questions from the discussion forum that was asked on the discussion forum. So Snehas is asking this question. That is saying that he is confused about this negative voltage. So while this is a comparator circuit during this moment, the comparator circuit was discussing in the class. Okay, so from here we are supplying an analog input of like 2.5 voltage. Okay, for 2.5 volt of analog input we are supplying, and we are comparing it with this 1, 2, 3 volt and 4 volt, like that. Okay, and what is the situation like if this value is greater? So if this value analog input is greater, so this comparator will give us value 1, and if this value will be less than these values, so it will show the value 0. Okay, so here what is happening, we are applying 1 volt to this positive terminal, and it is that 2.5 it is applying to the negative terminal. So he is confused with this term of like this terminal. Okay, at negative terminal, he is saying that it is minus 2.5. So I don't like this is a confusion. So this is a terminal only, this is not a negative voltage. Okay, so that's why like 1 voltage is less than this 2.5 volt. This is not this, we are not considering this terminal as a sign. Okay, so the discussion in the class is correct, and you may again go through it for like further for getting more information, okay, thoroughly. The next question was asked by Mr. Adik. So he said that, sir, normally every signal conditioning device gives output in current change because there is possibility of change in voltage. Also tell me what type of output provided by sensor is analog or both, or digital or both. So as we already have studied that, yeah, sensor, the sensor there may be analog sensors or there may be digital sensor. Okay, so both type of signal can be provided by from the sensors, and that's why we require that condition monitoring and the conversion devices. Okay, converters are required to supply those values to the microcontroller or some this microprocessors, because the microprocessor works on only on the digital signals. So here it is, the answer is mentioned on the portal. On the portal was like, the main purpose of using a signal conditioning device is to further process the signals and data from the sensors, so that the proper signals and the data can be fed to the microprocessor, so that necessary intended action can be carried out by the microprocessor. Okay, so sensor actually usually provide output signal in analog form, except for digital sensors, where necessary components are converted analog signal to digital form for integrated along with the analog sensors. The signal conditioning device receive data from the sensors, and their main function is to convert the data received into understandable electrical data, so that they can understood by microprocessor and necessary intended action can be carried out. So yeah, this is already there in the portal. You can read it from there if you have any confusion. I don't think the people who are in the class have this kind of confusion. Next question is asked by Rajesh. I think Rajesh hasn't joined the class today. Maybe of some examinations are going on or something like that. So okay, so but we'll take his question. He's asked about which operation is used in priority encoders. Okay, so we have already studied about priority encoders in last week. Okay, so priority encoders are what? Like priority encoders are a circuit or algorithm which receives multiple input and compress them into smaller number of outputs. So we have studied about 2 to the power n. So where n is the required number of output. So this, for if n is the required number of output, so this 2 to the power n is the number of inputs. Okay, so if we have like n is equal to 3, so it is 8. So we have studied in the class about 8 to 3 priority encoder. Okay, 8 to 3 priority encoder. If so, at this point of time of video, this 8 to 3 priority encoder was discussed in the class. Okay, so for more about like how priority encoders work, so this 8 to 3 encoders, so in that we use some logical gate operation. So this is a sample. I'm not like this is not the actual uh, that is that was discussed in the class. Okay, so this is a different logical operations that we have applied for same kind of what I can say encoder. Okay, so this has 8 input and it is getting converted into compressed into 3 output. Okay, so with the help of this logic, it is compressed. The data is compressed. The input signals are compressed. Okay, into three output. Okay, so yeah, priority encoders priority encoder employ this gating systems. Okay, logical gates to convert the data from like number of large number of data into smaller outputs, small number of outputs. Again, next question. This question is also again asked by this Rajesh only. So he wanted to know about servo motors. Okay, so yeah, let's discuss about servo motor. So servo motor is nothing. These motors are just of any type like AC motors or DC motor that we already have studied. So in addition to that motor, so this motor may be like it may be like AC or maybe DC. Okay, so with this AC or DC motor, there is a feedback circuit that is joined with that. Okay, so this feedback circuit makes this servo motor very important. So because these servo motors are utilized in for what purpose? For positioning. Okay, for positioning requirement. So it is a compare what is it? It is a option against that the stepper motor that we have already discussed. Okay, so in place of stepper motor, we used for a very precise positioning, we use servo motors. So in servo motor, there is an encoder which is attached with the motor itself, which is used to what I can say, which is used to compare the output. Okay, which is required and what is the required output and what is the actual produced output. So based on that, it provides feedback to the controller, and controller change the parameter that is required for correct output. Okay, and it gives its accordingly it provides signal to the driver, and driver drives the motor. Okay, so this is a complete circuit that makes a servo motor. Okay, so uh, how this is how a general normal AC or DC motor is converted to with the help of this feedback loop. It's a closed loop. It is a closed loop, and it is converted to a servo motor. Okay, so here I have a short clip, but I think again it will not play here. So I'll just try once if it play. No, it is not playing. So I'll just show you an external window. Yeah, so these are the components of servo motor. Okay, so there is a controller, there is a driver, and then there is a encoder and the servo motor. Okay, and these is the positioning where we require the positioning. Okay, so on supplying like this positioning is occur with the rotation of the shaft of the that servo motor. Okay, and the correct placement or the correct output is then identified by the encoder that is attached with this motor. So that provide the feedback to the controller, and accordingly that controller controls the motion, controls uh, the the required power or the power supplied to this servo motor. Okay, so there is a controller and then there is a driver again. So this will supply a feedback. This makes a feedback loop there. Okay, and based on this feedback from the encoder, the further operation of this, like, yeah, further signals are transferred to the motor, and then accordingly the positioning, it is used for the for positioning of components. So this servo motor is in like joined in two parts. So one is the motor itself, and another is a encoder. So yeah, so we are running out of time. If anyone have any question now, or any confusion regarding this session, so you are free to ask, and I will be happy to answer. If not, then we'll close session. Is there any query to anyone? So this is a QR code for my web page. If you want to connect with me, you can scan this, and it will take to my web page, and you can ask a question there, or any, like, you can connect with me. Okay, so so we'll meet again in next week in the same platform at same time. So till then, happy learning. So keep learning, and if you have any doubt, you can post it on the discussion forum, or else you can ask directly, join this class and ask me the questions. For the question that are asked today, I will just discuss with Professor Joshi, and I will try to get back to you all in next week. Okay. Thank you all for joining this session.